Hello everyone, it's Mike Levin, Wednesday, July 20th, 2016. Coming up on 9 a.m. and I thought I'd say a few words about the system I'm making now. I'm actually in the process of naming it, and it is the third iteration of a SEO investigation product whose, I guess, history, prior implementations goes back to about 2010 when I did a version of this for 360i called Tiger, at a time when I was completely innovating new capabilities. People were not working this way at all. And it created quite a splash, and was great for 360i. But when I left, I decided to re-implement it, black box it with everything I knew then. And that was around 2014. And the Tiger version from 2010 actually had some heavyweight dependencies, including the whole Apache web server itself. And I was using a way of incorporating Python into Apache called mod_Python, which was not even the standard for Python using web servers, which is WSGI or Whiskey, some people call it. So when I did the 2014 version called Manipulate, I took the whole web server dependency out of it and actually used Python's own built-in web server and kept all the dependencies very light so that it could actually live on my Linux distro called Levinix. And the whole Manipulate distribution, everything required to get it running, was distributed out into a 20 megabyte, a teensy tiny download that you unarchived and ran, and you got a virtual server on your desktop, which would build itself into a Manipulate server. So you'd have a whole web application running on what essentially expanded out to about a 60 megabyte footprint, very tiny still. It had no graphical user interface, no desktop on this virtual machine, aside from the web browser, which was the Manipulate app itself. And I guess the reason I did it this way is because I wanted it to be a Python learning experience, an opportunity for everyone to run Python and get the exact same results no matter what desktop platform they were on. And in those days, there was really no way to install Python on your local desktop machine and have the exact same experience across the board for a whole diverse array of hardware platforms and even users and versions of operating systems, etc. It's just too many moving parts. And that's where the virtual machine came into play. Levinix, my distro, which was a respin of a very, very tiny version of Linux called TinyCore, and the virtualization platform called QEMU. And it was great. It was a glorious product. Still works, and I'm probably going to keep Manipulate completely intact in the GitHub repo, mostly for archival reasons. The people who are following Manipulate in particular, I don't want to swap out the repo with version 3, which I'm here to talk about now, which in 2016 things are very different than they were even in 2014. Apparently there was a project that was in development, and it was really out there for a while, called Jupyter Notebook, which gave a fairly consistent user interface to Python across heterogeneous hardware platforms. So that was really part of the puzzle, but you had to get this thing installed, which was its own challenge. And along comes Anaconda from Continuum, which is essentially a bundle of Python packages under one unified installer, so that it gets all these nuanced little details of running Python consistently across many different hardware platforms correct, including all the strange little difficult to get installed dependencies. The classic one here is NumPy, because when you try to install NumPy, it tries to optimize it for your particular hardware. NumPy is a matrix analysis package, so it processes rigidly structured tabular data, X by Y, in other words, spreadsheet-like data, but massive amounts of it, massively fast, because it's running it in not really Python, but through APIs that Python provides to compiled, optimized C components. And getting that installed on your Windows desktop, your Mac desktop, let's just say your results may vary, but not so much under Anaconda. It just works correctly every time. They seem to have fairly robust and well-supported installer. They seem to be making a business on this, even though it's all free and open source, so that I guess you can rely on it, at least as much as you can rely on my tiny virtual machine. QEMU will be around forever, so maybe my stuff is a little more long-term reliable, but nonetheless, we're talking about being productive under the next 2 to 5 years before everything changes again. And for that time period, I foresee the Anaconda install as being the great reliable way to get Jupyter Notebook installed, which is the great reliable way to have consistent, reliable, teachable, controlled execution environment Python. And so that's going to be the basis for iteration 3 of this SEO investigation project. Now, as I started working on it, a few names came into play. I like Goodsheet because for the components where it's going to read and write with Google Spreadsheets, I really want to brand that section of it as Goodsheet or Happy Sheet. I'm going back and forth between possibilities. And I don't want to get rid of the Pipulate name, so that's 2 names, Goodsheet and Pipulate. And now finally, those are actually module components to make iteration 3 possible. And so what should that be called? And I'm playing with different ideas, and I'm sort of settling in on SEO Notebook. So today I'll probably create or rename an existing repo I have in GitHub to SEO Notebook, which already has Goodsheet and Pipulate in it, with a few innovations that I made yesterday, which actually has turned it into iteration 3. With the least code that I've ever used in such a system. So, what do I get out of doing it in iteration 3 aside from the Jupyter Notebook UI, which is wonderful and reason alone for it? But I get massive levels of understandability by virtue of massively less code, infinitesimally less code to achieve the same results, through a combination of having switched from Python 2.7 to 3.5 and taking advantage of the new capabilities in Python, and also just my increasing knowledge of Python and all its nuances from all the books I'm reading, fluent Python, concise Python. There's all kinds of books I'm reading now, which are greatly a result of listening to the podcasts. I keep mentioning Talk Python to me and Partially Derivative, which are 2 of the easiest ones to listen to. And I talk a little bit more about testing code, which is nice too. But then there's this other one that I don't mention a lot, and they're already up to like episode 66 or something, and I'm trying to catch up on that, and that's, I believe, Podcast Init. And it's a lot harder to listen to. It's a lot drier, it's a lot more monotone, perhaps a little bit like me. So, at any rate, my mind is sort of bursting with all kinds of different approaches I can take. And I was actually trying to avoid the use of the eval statement, given the nattering nabobs out there who think eval is evil and always will and will never be convinced otherwise, because they came through their comp sci courses through a much more traditional static compiled route, and they're static thinkers and are not big fans of self-modifying codes, no matter the capabilities it brings, the context it's in. And so I got up to the point in Pipulate where inevitably I have to find a way to take a list of function names represented as strings that you get from inspecting a module with the dir command. So if you do dir and surround in parentheses any module name that you've imported, you get a list of everything that's available in that module, but as string representations, quotes around it. And so what I needed to do is I needed to call any one of these functions conditionally on encountering it through parsing the input. When the input gives reference to one of these function names, it needs to be able to call the function. And so I looked at the most Pythonic and elegant and brief way to do this. And some of you might know that Python doesn't have the switch statement, even though it totally could. But Guido van Rossum had essentially drawn a line in the sand saying the Pythonic way to do switches is to create a dictionary. And dictionaries are these name value pair combos, and you plug a name in, or you plug a key in. They're key value pairs. You plug a key in and you get the value out. Now here's the super interesting thing. Because functions, and for that matter classes, are first class objects, first class data types inside Python, they can be used in any location that you could use a variable name, such as the pair part of the key value pairs in a dictionary. Consequently, you can actually create a dictionary whose keys are the string names of a function and whose values are the function itself, the representation in memory, the pointer to where the actually ready to execute or run function resides. And to create this key value pair of function names and function references, you have to actually, given a list of string names, string literal function names, you actually have to use the eval statement, unless it's in global. If it's in global, you can use the callable aspect of global to create a instance of the function name from global in memory. But when it's just an external module, I have not quite figured out how to make an external module of just functions, not classes, because I know how to make classes callable, but an external module of plain vanilla Python functions into callable, making the functions themselves within the module callable if you are sitting on their string names without using the eval statement. I use the eval statement. I have now an elegant, ready-to-use solution where I can invoke any one of these functions by name and feed it as its parameter using the asterisk keyword arguments trick in Python, which is essentially feeding a dictionary as a function call parameter to a function, and then you have that sitting inside your function ready to be referenced as a dictionary. So you can essentially go around all the building of an API of a function. And the building of an API of a function is choosing what values to put in the first position, or what variable name to put in the first position, in the second position, in the third. And then you make these parameters position dependent. Bad idea? you can use name equals parameter and then make them not position dependent, which takes you a step further towards flexibility. But then you can just go all the way and say, you know what? All the parameters to this function are just going to be passed to it through a dictionary object. There's all kinds of hybrids on top of that. You could use positional plus star star keyword arguments. And I'm just going to use star star keyword arguments so that every pipulate function now can consistently be written knowing that you're just going to be passed in all the values from the row that that function call was generated from. So again, the pipulation process is scanning spreadsheet top to bottom, left to right. First row gets treated special and establishes the function names and the input parameter names. And then every subsequent row is some sort of request. One line of a greater job request, where a value such as a URL value is taken, fed into a function such as page authority, the value returned, plugged into the correct position on a row object, and then the row objects are all batch updated back to the spreadsheet after the values have been put in. And that's the pipulation process. So these functions like page authority need to know about the parameters they can expect to be seeing. And everything gets very simplified if you just feed it every value from that row, and it can pick off those it cares to do with what it will. And so that's iteration 3 of Pipulate, which I think I'll be going with the name SEO Notebook, because it'll be under Jupyter Notebook, which will have as components Pipulate, that'll house all the functions that can be used, and Goodsheet, which will provide all the methods for interacting with a Google spreadsheet. So that Goodsheet will be able to be swapped out with other things if you wanted to do this against CSVs or anything essentially that Python can interact with using the shelve API, and that'll be a whole nother video, because there's a way to interact generically with any key value store database through Python, so that you don't have to keep doing new implementations for different databases. Standard API of shelve. And then finally, one of the tricks I innovated yesterday, and I'll wrap up here because I'm at work. Instead of Goodsheet and Pipulate being .py files being imported as external modules, I am importing them as actual .ipynb, IPython Notebook files, meaning under Jupyter Notebook, you can have all 3 loaded at once and not have to deal with editing text files either through an IDE or Vim or anything, and just have all 3 loaded in Jupyter Notebook and modify the whole system however you like, adding Pipulate functions as you need them, changing the way the reading and writing to Google Spreadsheets works. Basically all the details of the system can be adjusted and modified through just these 3 files, which provide the Jupyter Notebook interface for actually interactively running the code and revising it. So it becomes not merely agile and flexible code, it becomes infinitely adjustable, infinitely customizable, and a really, really good basis for your SEO secret weapons, because you can push back out to GitHub anything you like, or hold back any of your innovations for yourself as your own secret sauce. Anyway, that's where I'm at today. That's some of the stuff I'll be doing today. Hopefully I'll do one more talking head video to show you a little bit of this, and thanks for joining me. Hope to see you again soon, and don't forget to subscribe.